mean something more to you by the end of today than it did in the beginning of it. So really today's lesson is all about types and changing between different data types. I think so far we've looked at numbers and strings and booleans. But in programming, a lot of times it's not just what you're given and you do something with that. It's like you're given something, and before you actually take any meaningful action with it, you actually need to transform it or change it to a different thing. And so that's what coercion is all about, right? Coercion just basically means changing from one type to another. So we'll talk about two types of coercion, both explicit and implicit, and then we'll talk about a special type of coercion where we're dealing with a lot with boolean boolean data types. Booleans can be thought of, just as a quick refresher, booleans can be thought of as the most basic of data types because there are only two possible values, true or false, right? There's no maybe, there's no perhaps, it's just everything's either yes or no, a 0 or a 1. So it's binary. And so because of that clear cutness, it's actually a very common data type to be used to use in programming, because computers, I mentioned this to you guys earlier, computers are extremely bad with ambiguity. They operate well with exact precision, and you really can't get any more precise than a true versus a false. So the types that you've already seen, numbers, booleans, and strings, are all what we call primitive data types. There are other primitive data types too, like nulls, undefineds, and symbols. But for now, let's just keep our focus on the first three: numbers, booleans, or numbers, strings, and booleans. There are other complex data types too that we'll talk about later on in the cohort. Things like functions and arrays and objects. And just so we're aware, and we won't spend too much time in it on this class, but we will in a later class. The major difference between primitive and complex data types is that complex data types can be changed, whereas primitive data types can never be changed. They can only be replaced. We have an entire class. Gosh, your schedule is a little bit strange because of the Christmas holiday. So I think next Wednesday on something called pass by reference versus pass by value, where we'll dive a lot deeper into this idea of what does it mean for something to be primitive versus complex. But for now, just kind of take our word for it that these are the two data types that exist in JavaScript, right? Primitive and complex. And on the primitive side, we're mostly focusing on numbers, strings, and booleans. So given that those are the types, when we talk about coercion, really it's just a fancy way of saying let's change the data from one of those types, either a number, string, or a boolean, to another type, right? Another number, string, or a boolean, or maybe something else too. And so coercion just means when one type of value is changed to a new type. And explicit coercion is actually one of the more like clear-cut ones, because it's when we actually use the built-in global object class to create a new value of a type. Now that may seem like a lot of words that mean nothing to you just yet, but if I showed you in code, hopefully it's very much clear. Here on line 6, I've created a variable called num. I set equal to 10. On line 7, I console log out this type of num. Now, notice how type of doesn't follow the camel case convention, right? Camel case convention means that the O and of should be capitalized, but it's not. And the reason for that is because type of is what we call a reserved word in JavaScript. That is, it's part of the actual JavaScript language. And so in order for us to note that these reserved words mean something different, in this case, it's not camel case. It's actually something that we can just write as is, just like that. But know that type of is a very special reserved, not necessarily a function, but it's a reserved word in JavaScript. It's something very, very special. And essentially, it just tells you what the type of a given value is. Now, on line 6, we create a variable called num. We give it the value of number 10. On line 7, we console log out the type of that num variable. On line 9, we create another variable called string with a lowercase, and it's equal to this capital string, and we pass in the variable num. On the first day, when we talked about variable naming, one thing I mentioned was just that, hey, when you capitalize the first letter in a variable in JavaScript, it actually means something, right? And here we kind of see an implementation of that. Whenever you capitalize the first letter in a variable in JavaScript, what you're really saying is, hey, I'm talking about a class. Now, classes we can do its own, not just class, we can do its own course on classes. But for now, just note that classes are basically kind of existing archetypes, existing molds, if you can call it that, of things that already exist in JavaScript. And in this case, the JavaScript language actually, it comes with the string class, the number class, and the boolean class, right? These things are all pre-existing, and they're essentially the templates for why we are able to create strings, numbers, and booleans. And so here on line 9 on the right hand side of the equal sign there, when we have the capital S string and we're passing in the value num, what we're really saying is, hey, let's call this string class, this string global object, which is pre-built in JavaScript, and let's pass it into this value. And what JavaScript's going to give back to me is going to be the string version of whatever variable you gave it to me. If you gave me a string, I'm going to leave it as a string. If you give me a number, I'm going to give you back the string version of that number. If you give me a boolean, I will give you back the string version of that boolean. And so on line 9 here, whatever the right-hand side is going to give back, we capture it in this lowercase variable called string, lowercase string on the left-hand side. And then on line 10, we console log out that variable. And on line 11, we console log out the type of that variable. So when we look at our printouts, on line 7, right after I made the variable num, what's that type? Well, it's a number. That's a type. Okay, cool. On line 9, I've now taken that number, I fed it into the string global object, and I've converted it into a string. On line 10, when I console log out that new variable, I see as a 10, but when I console log out the type, it's actually not the number 10, it's the string 10. Right? And so we call this explicit coercion. It's because we are very, very clearly on line 9 there saying, hey, let's invoke this string class and let's pass something into it and get back a string value. Okay, that's explicit coercion. We are being very clear about what we're changing something to. Explicit coercion actually happens across any data type that we can imagine, right? So here on line 6, we actually create a variable called string. It's lowercase, so we're not dealing with classes just yet. And the value of string is not the number 1,000. It's the string with 4 characters. It's a string 1000. Okay. And on line 7, we console log out the type of that variable string. Now on line 9, we create a variable called num, and here we invoke our number global class, and we pass in the string, the variable string, and we do the same thing as before. We console log out the variable, we console log the type of, and you'll notice initially on line 7, 1000 is a string, it's not a number. But after we coerce it into a number on line 9 there, on line 10, when I console log out the variable num, I get back 1,000, and when I console log out type of num, I get back the number 1,000, or I get back number, which tells me that 1,000 is it's no longer a string, it's a number. Everyone good so far? Yes? Someone?
Kinda. Yeah, sorry.
Yep.
Awesome. That can be used to change any variable, right?
Yep. Yeah. So any of the classes that we've talked about so far, the numbers, strings, or Boolean classes, you can pass anything into it, and it'll just give you back the string number or Boolean version of that value.
Okay. Oh, yeah.
Sorry. Go ahead.
Oh, just that's fine.
Okay. Cool. So why do we keep talking about it being explicit coercion? What's the opposite of that? Well, the flip side of that is something called implicit coercion, which also changes the type of value, except now we do it a little bit more subtly, right? We don't actually call the new data type that we want. Instead, we have JavaScript kind of handle it for us behind the scenes, which is both very helpful but also very dangerous if we are not clear about what's going on. So let's take a look at an example. Here on line 1, I've created a sum. It's the number 10 plus the number 20. Well, that gives me back 30. Cool. On line 3, I've created this variable called concatenated string. It's the string 10 plus the string 20. When I add those two together, what do I get? Well, as you've probably seen, if not before, you are seeing it now. When you add two strings together, you get back the string 1020. Right? That's how I add two strings together. Just like how I add the string hello to the string world, I get back the string hello world. Okay. But what happens when I add in a number plus a string? And the answer is, drumroll please, when I do that, I actually get back the string version, right? So on line 1 there, I've printed out the sum of 10 plus 20, which is 30. On line 3 there, I've printed out what happens when I add two strings together. I get back even bigger strings. And then on line 3 there, or on the third printout, when I added the number 10 to the string 20, I got back the string 1020. In this case, what I've basically done is, based on the output, it's clear. On line 5 there in the not sure variable, what I've done is I've essentially converted the 10 to a string, and then I concatenated the two together, as opposed to me converting the 20 to a number and then adding the two numbers together. Okay, and so this is what we call implicit coercion, right? A data type is being changed, but it's not explicit, right? Nowhere on this page did I actually manually convert that 10 to a string. But JavaScript saw the plus sign. It saw that I'm trying to add two different data types, and it just made a decision on my behalf of saying, hey, whenever I'm going to assume that whenever you try to add a number to a string, what you really want to do is convert both things to strings first, and then just shove it together. Yeah, and so the plus operator in this case is actually doing the work for me, and it will implicitly coerce a number to a string if I try to quote unquote add it to another string. And so here on line, well, I guess the numbers are a bit off here, but assuming line 6 here, I create a variable called will be a string. I have the string 10 plus the number 20 plus number 30 plus number 40 plus number 50. When I console out the output, I get back the string 10 plus the number 20. Well, if we just kind of go left to right one step at a time, what's the string 10 plus the number 20? Well, JavaScript is going to see that and say, well, whenever you try to add a string to a number, I'm going to convert both things to a string first and then shove it together. So now the string 10 plus number 20 becomes a string 1020. Okay, then if I try to add the string 1020 plus number 30, well, same thing. I'll convert the 30 to a string, shove it together, and I'll get 102030, and so on and so forth until by the end of it, we reach the very end, which is gives us a massive string of 10, 20, 30, 40, and 50. Now, like I said, computers operate not as a whole, but very sequentially in small parts, right? And so if I took a look at another similar example but with a twist, I actually get back something very different. Here, I create a variable called also a string, and it's equal to the number 10 plus 20 plus 30 plus 40 plus 50. Now, what happens if I try to add these two things, add all these things together? Well, the really kind of, if we were to walk this through logically, we would actually do it one step at a time, and we say, okay, great, first things first, what's 10 plus 20? Well, that's number 30, right? Because I'm adding two numbers together. There's no ambiguity there. Okay, well, what's 20 plus 30? Or what's 30 plus 30? Well, that's 60. Okay, and what's 60 plus 40? That's 100. And what's the number 100 plus the string 50? Well, now we do let's convert everything to a string first and then concatenate it together. And so when we do this, our output actually becomes this. It's still a string, but now the string is 10050, because as we move from left to right, the first four things we're adding are all numbers. So there's no coercion involved. The coercion only takes place on the last step when we're trying to add in a number to a string. Any questions so far?
No. We'll be getting into the, I guess, the exclamation point operator.
Yep,
next
we will.
Signs, right? Okay, I'll wait.
Yep. Cool. Okay, so basically in JavaScript, there's two kinds of equal signs. There's the equals equals, and then there's the equals equals equals. So double equals or three equals. And basically the rule of thumb we just want to leave you here with is always use the three equal signs, because the three equal signs is by far the most precise one. And what it does is it compares both equality based on the data type as well as the data value. If you use a double equal sign, what the double equal sign will do a lot of times is it will make assumptions on your behalf about what types you want to change things to first and then compare them. And that's something that could be useful in very rare cases, but in general, the triple equal sign is going to be the one that you want to use because that's the most precise. So as an example, here we have a bunch of double equal comparisons that all are true, but some of them don't quite make sense, right? And so I won't go into the details of what double equals is trying to do, other than to say that it's making some coercion assumptions on your behalf that you probably don't want to make. So yeah, so once again, when in doubt, always be as clear and as precise as possible. Okay, so now we're going to move into our last section, which is on booleans and this idea of truthiness too. Okay, so we've talked about how to convert things between a number and a string, and I think for the most part it's pretty clear, kind of like, okay, well, a number could be put in a string form, and a string, if it's a number, could be a number, right? That's pretty straightforward. What about booleans? Booleans, once again, have two possible values. Everything is either true or it's false, no middle ground. And so everything in JavaScript actually can be converted, or is able to be converted into a boolean. And so when everything is converted into a boolean, there's only two possible things to determine, right? Either when I convert this value to a boolean, it's going to be true or it's going to be false. There's no other outcomes. And so we've actually developed a terminology for this called truthiness or falsiness. And so whenever we say a value is truthy, what we mean is when I convert this when I coerce this value into a boolean, it's going to give me true. And when we say a value is falsy, it means when I coerce this value into a boolean, it's going to give me back false. And so here on line 3, notice how I'm using the capital B, the Boolean class. I'm converting this string, I am a string, into a Boolean value that I'm storing this variable called new bool. And when I convert it out, or sorry, when I console log it out, I get back true. And so, yeah, and so that's what the difference between truthy and falsy are. Truthy means values when you convert it into a Boolean are true, they're called truthy. And when you coerce a value into a Boolean it's a false, then those values are called falsy. And almost everything in JavaScript is truthy, and so it's actually not even worth your time to remember what's truthy. Instead, it's actually a lot easier for you to remember what things are quote unquote falsy. And there are only 6 possible values in JavaScript that are falsy. That is, when you convert into a Boolean, you get back false. And those values are either an empty string, the number 0, nulls, undefined, this thing called NaN, which stands for not a number. You basically get that if you try to coerce, for example, a sentence into a number, JavaScript will say, hey, it's not a number. And that essentially is a falsy value. And then we didn't list it here, but obviously the value false itself. Oh, shoot. Running low on battery. Huh. Okay, see how far I can go. Yeah. So, I'm really sorry about battery, guys. I'm not near outlet right now. Okay. Yeah. So those are the only 6 falsy values. It's the empty string, the number, nulls, undefined, and the value not a number. Okay. Everything else when you convert to a Boolean JavaScript is going to give you back a true. And so if you remember how we had a conditional statement, right? A lot of times in our if statement, well, basically in an if statement, all we're trying to do is figure out is, hey, that thing in between those parentheses, is that a true or a false? Okay, if it's a true, then we do whatever is in the if block. If it's not, then we do whatever is in the else block, right? And so here on line 4, if I have a if and I have the number 5 in the parentheses, what JavaScript is really saying is, hey, that thing in between the parentheses, is it true or is it false? If it's true, I'm gonna do the if block. If it's false, I'm gonna do the else block. In this case, it's a number. And so is that number true or false? Well, every number is true except for 0 and not a number. And clearly I'm dealing with the number 5. So therefore it's true. And therefore when I run this function, I actually get back in the if, which means that this is the same as true, and I'm going to execute my if block. Similarly, if I have something like this, I have an if else block, and inside of my conditional, I have the string apples. Well, same thing, right? Is JavaScript try to coerce whatever is in between the parentheses into a Boolean, and it's going to ask you, is the string apples, is that true or false? Well, it's true because it's a string, and the only false string is a empty string. So therefore, it's going to put it in the if block. And so once again, JavaScript, whenever you have a conditional statement, whether it be a while loop or an if loop or anything, JavaScript will always try to implicitly coerce everything you put into the if block into a true or a false statement. Here on the top, if 10, well, 10 is truthy, so we're going to do the if block. On the example on the bottom, it's saying if 0, well, 0 is a falsy value, so if the if is false, then we go to our else block and we console log out no. So we get yes in the first case and no in the second case. Any questions so far? Oh, sorry. Everyone good so far?
Yes. Yep.
Cool. Do you guys mind holding on for like 2 minutes while I go grab my charger really quick?
No,
Yeah,
take
sure.
care.
Yeah,
No
sorry about that, guys.